Okay, so in this video we're going to look at bearings. There are three key things that we've got to remember when we're doing a bearing. So bearing is basically an angle, but it's written as a 3-digit number. So for example, if we look here, if I had the angle of 65 degrees, I would write it as 065. We must always draw a north line from where we start, and we must always measure in a clockwise direction. So those are your key three facts that you've got to remember before we can even consider doing a question. So I'm going to look at three styles of questions that we might see in an exam. So the first one, I might just be given 2 points. I've called these point A and point B, and I'm asked to calculate the bearing of B from A. So one of the really important things here is trying to figure out where I'm starting and where I'm measuring from. So it's telling me the bearing of B from A. I've underlined from A because that means that is where I'm going to start. When I know where I'm starting, that is where I draw my north line. So I'm going to grab my ruler and I'm going to draw, hold on, the other way around. Let's just do that again. And I'm going to draw a north line. So a north line pointing directly up. I then need to measure to B. So the easiest way to do this so we don't make a mistake is to draw a line in between my 2 points, A and B. I know I'm starting at A, and then I need to use my protractor to measure this angle in here. So I'm going to take the protractor. Most of you will have a 360 protractor, so I will use that as a full protractor. Let me see if I can make mine a little bit smaller. So remember, I'm measuring in a clockwise direction. So I want the 0 on the bold line, which is my north line. So I'm going to measure it, get it as accurate as I can. Slightly easier for you to do than it will be for me. And then I'm going to measure round from all the way round onto this line here. So mine probably, yeah, is straight. It's going to be about 62 degrees. So I'm going to change that, and we know it's 62 degrees. However, remember, if I write it as that, I'm going to lose a mark. I need to write it as 062. I'm just going to take away my protractor and have a look at the next question. So this time it's asking me to calculate the bearing of A from B. So remember, I've underlined where I'm going to start, so I'm starting from B. Whenever I know where I'm going to start is where I draw my north line. So this time I need to draw another north line. To make sure I've got my arrow in the right direction, yep. So I'm going to draw a north line here. So I'm starting from B. One of the rules is I always measure in a clockwise direction. So that means I need to measure all the way around to here in a clockwise direction. Alternatively, you could measure this part and take from 360, but I'm going to try and get into the right habit of making sure I always just measure in that clockwise direction. So again, I'm going to line up the best I possibly can. As I said, you'll find it slightly easier than me trying to do it on line. It's not the easiest thing to use. So it's on 0, and I'm going to measure round to my line. So I'm using this scale all the way around the top here. So all the way around, and it comes out just before 240. So I'm going to call that 239. If you remember, it's already in, isn't it? It's already in 3 digits, so I don't need to do anything else with that question. So for a question like this, remember, underline where you're starting from. Draw your north line. If you have 2 points, join those 2 points up, measure in a clockwise direction, and then write your bearing as a 3-digit answer. Now we might be given a question in a slightly different format, which is the next one here. It looks very similar. I've got 2 points. I've got point A, point B, and the first part of the question is asking me very similarly to find the bearing of B from A. So I'm going from A, which means I need my north line at A, so we'll do that before we do anything else. So again, I'm going to get my north line, I'm going to draw it from A, and then going to join my 2 points up so I can get an accurate reading. So I'm going to join from here, from the centre of this cross to the centre of here. So the first one, the bearing of B from A, means I'm going to measure this angle here. So I've lined it up on 0, and if I read round, it comes out at 110. So that one's 110 degrees. I don't need to do anything else because it's already written as 3 digits. Second one is the bearing of A from B. It says from B, which means I need another north line at B. So I'm going to go to B, I'm going to draw my north line. Remember, I must measure in a clockwise direction. So this time I need to measure this angle going all the way around here. So pick up my protractor, get it marked, get it lined up and measure round. And if we have a look going all the way around, it's just before 290. So I'm going to write mine down as 289 degrees. So that's the first part done, which looks exactly like the previous part of the question. However, there's now an extra step. It says use the scale 1 centimetres to represent 20 miles. From your diagram, work out the real distance between points A and B. So I need to find my ruler, and then I need to measure the distance between these 2 points. Again, this will be much easier for you to do than me because it's a little bit difficult lining these up. I'm going to do this as best we possibly can. Yep, not very good at doing this. Right, let's try that. Not perfect, but not far off. Now if we notice, we're going from here to here, so I would say it's less than 10 centimetres, it's definitely over 9.5, so it's about 9.7 centimetres. I'm just going to make myself a note. So it's 9.7 centimetres. Now I know what my distance is, I then need to work out what the real distance is. So I'm just going to make myself some notes. So I know that 1 centimetre is equal to 20 miles. So how am I going to get to 9.7? Well, I'm going to have to multiply 1 by 9.7. I know we don't have a calculator for this, but actually we can ignore the 0 initially. And if I just do, well, that's 9.7 times by 2. If we struggle, we do 9 times 2 to give me 18. We do 0.4 times 2 to give me 1.4. So I know in total that gives me 19.4. I then need the extra 0 on it, so I know that's going to be 194 miles. Okay, so the final part of the question. It now tells me that we have an extra location, and this location is C. So 140 miles from B on a bearing of 110. So C is from B. That means we start measuring at B. We know it's a bearing of 110, but we need to figure out what the actual distance is. Well, we know that 1 centimetres is 20 miles. So this way, I'm going to do it slightly differently. So I've got 1 centimetres equals 20 miles. I want to get to 140 miles. Well, how many times does 20 go into 140? So we should know that that is 7. So therefore I need to draw my location 7 centimetres from B, but on a bearing of 110. So I'm just going to move a ruler out of the way, and the first thing I'm going to do is I'm going to do a bearing of 110, and it's from B. So put my protractor back on B, get it as lined up as perfect as we can. So on a bearing of 110, which is here, so I'm just going to draw a little dot. So when I move my protractor away, I can see where that is. And now I need to measure 7 centimetres in this direction. So I need to line it up and just see if I can move this slightly so it's a little bit more accurate. Nope, let's go back that way. Like I said, you'll find this much easier because you'll be able to line yours are a lot easier than I will. That's about okay. So I need to measure 7 centimetres, which is here. It's on the correct bearing because my bearing is there, so 7 centimetres would be here. I'm just going to put a dot. Move my ruler out of the way. So my location C, it says on your diagram mark C with a cross. So here would be C. This distance to this distance is 7 centimetres and this bearing is 110. Okay, final type of question we might look at. So this question here states really clearly it is not to scale. So the moment I see a bearings question not to scale, that means I need to put my protractor away. It is not going to help me. I'm also just going to get rid of my ruler for the time being. Now what it has shown me on here is that I have two north lines. Now if we think about north lines, they're both going up in vertical position and therefore these two lines would be classed as parallel lines. So that's going to help me. So the moment I see a bearings question, it's not to scale. I need to start thinking angles on a straight line, angles on parallel lines. So for each question it's asking me to work out the bearing of B from A. So from A initially means I'm starting at A, I'm measuring in a clockwise direction. Well, I already know this angle here is 72. So angles on a straight line, so I'm going to do 180 and I'm going to subtract 72, which gives me an answer of 108 degrees. That one's done. So I've done A initially. It then says A from B. So, and this time I'm going to have to measure all the way around here. But remember, I've said I've got a pair of parallel lines. Therefore this angle and this angle have to be the same because they're corresponding. So this angle here is 72 degrees. If I now do angles at a point and I do 360 and I take away 72, I'm therefore going to work out the angle that I'm interested in. So final step, 360 degrees, subtract 72 degrees. If we calculate that quickly, it gives me an angle of 288. So this is the answer for part 2, and this is the answer for the first part. Same on this one here. So again, remember it's not to scale, so we can't be using the protractor. I am starting at A and I'm going to B. So this is the first one I'm working out. Well, I already know that this angle here is 262, so I'm going to do 360. I'm going to subtract 262 degrees and work out what we get. So 360 take away 262 gives me 98 degrees. And so that's my answer for part I. I'm now interested in A from B, so I'm interested in all of this. Well, we just spoke a moment about using angles and parallel lines. So I know if this is 98, I can work out this angle because these would be co-interior or supplementary angles, which means I would do 180, take away 98, so this angle in here has to be 82 degrees. To work out the bearing of A from B, I then just have to do 360, take off 82 and get my final answer. And that comes out at 278 degrees. So it's not tricky, just remember the moment it says not to scale, you're going to use your rules such as angles on a straight line, angles in parallel lines, or angles around a point.